Welcome back to Mathematica for Architects. Now we are working on making a map of the friendship of words in a book, which characterizes the language of the book and which will enable us to compare books in their language and to get friendships of books or friendships of sentences. So this will be a little lonely, and for performance reason we have to re-implement the story of the chapters before. So let's start. We always have to check whether we are connected to the properly connected to the library. Now I prepared a new function. It's the book selection menu, so we don't have to look it up. So now we are with Christoph Alexander, that's fine. And we check the MTP book selected. This is working pretty well. Now we need the list of words. We had a function for that, so we call say at words as the MTP book decorated word. I'll look at the selection word sequence created 1. So of our book selected. So these are the 100,000 words of the pattern language of Christoph Alexander, so we don't want to have that. So we also had the list of the words 100, and this is in the meta. We saved it in the meta to increase performance. We already saved it in the meta data, so we can look it up in the MTP book meta read, and we had of the MTP book selected. We see that this is a key, and these are our 100 words, so we can use the word here and take it as a string, and these are our 100 words. We just want to have the key, not the frequency, so therefore we the simplest way is just to transform the association to a list. This is with normal. Put it like this. Now we have a list, and then we can work with list selection, which means we want to have all the elements, and we want to have always the first element of the sublists. And here we are with the 100 words. So we don't want to work necessarily for all the 100 words and their friendship relations. Therefore we say number of words should be, for example, 36, so it's a subset. And this means our words 100 should be words 100 from 1 to number of words. So this is our list we want to work on. So as we did before, we now need the selection. So this is a word 100 sequence. So it's a sequence of the words, of the prominent words in the book, and we want to forget all the non-prominent words in this words list. So we this is a select of the words, and we simply say member Q, as discussed in the last tutorial, member Q words 100 if this element pure function, if the if a word is member of this list, it should be part of the new list. If not, get rid of it. So we have 15,000. The sequence is 50,000 words. So this is our word 100 sequence. So now our word we want to get the calculator right is, for example, what do we have? For example, place. So this is our word we want to check, and we get the positions. of this word, no, in positions is, or is position of word 100 sequence and word. So it's a long list, and we have to flatten that. We don't want to have a nested list. So these are our positions. Then, as discussed in the last chapter, we have to check if we are in the beginning or at the end. So at the lengths of the word 100 sequence. This is 15,000. And then we can look up our last implementation, for example like this, just to show you how it works. We had the book, word, friendship, or context. This is what we implemented last, and this is different versions with different parameters. This is what we discussed with this length and word. So there should be only one, but I'm working on it. So what do we have here? Words, this is here. We have different naming, so we have to check a little. So words 1 is no word sequence. So we have the max of 1, length is here, positions is here. This should work. Yeah, good. But we want to have, for example, here a broader range of it. So now we have these things. If we are, for example, at the beginning, what we will have, for example, if we look for people, then we have the phenomena. These are the positions, and these are now the that they don't have, if at the beginning or at the end, they don't have 3 neighbors. So therefore we have to select this here and ask whether they definitely have, if we say length, 7 elements. Length of this equals 7, pure function, as a selection criterion of this list. So now our list of 1,350, we call that talks. These are the talks of this word, whether they are definitely 7. So therefore talk 1, our talk we want to work on is talks of 1. So this was people, and these are the friends of the people talking. So because we have only 36 concepts, this is of great repetition, but this doesn't matter for demonstration. So we can have to do hundreds later on, but now it's better to control these things like this. So now we want to say that if people is talking to people, this gives, because it's direct neighbor, this gets 3 points, 2 point, 1 point, 3 point, 2 point, 1 point. And we call that weight. There's a weight list, and we say it's 1, 2, 3, to itself is nothing, and then 3, 2, 1. These are the weights. Now we have to give weights or stars to, or points to this conversation here, which can be done. These are the points. Equal is a transpose. If we have 2 lists, we can combine them, look that up. If you don't, it's always like that. So if you hustle and don't understand, go to the documentation, yeah, here, and then you see how transpose works. You have a list of 2 lists, and then first, second, you see here. Yes, this is what we want to have. So we make the same thing and we say doc is a list, weights is a list, put that, transpose it, and here we have building at 1, building at 2, building at 3, people, well, so these are the points. Now we can do the points on all the talks. So therefore we simply make that a pure function and map it to the talks. And here we have all the points. But in a list of lists, so we have 3 hierarchies caused by this transpose, and we want to get a little, we want to narrow it down by 1. So we say flatten, look it up if you don't know what it is, flatten, and now we have a nice list of lists with points. So, next step is that we need a kind of account. So this is about the friendship. Friends. Friends are a table, and they get points. No, friends are our words. This is our, no, we have the friendships. Let's look here. Table, get no points, and we have the words 100. So this is length of words 100. So let's look what words 100 is. So then you understand what we intend to do. This is words 100, and we say I got likes from building. The building or our word here is place or people. People is friend with people, gets points from building, gets points from make, gets points from space, gets points from place, and so on. So therefore we have to put these here, and we say these are keys, and we have to get them numbers. So this is done with map indexed, and we say 1, look it up how it works, is first of, is a little uncomfortable, but this is the way how to say people is on the first, building is on the second, and the last is roof. This is the counting of likes of roof. So now make that an association to have it simpler in use. So now we have an association, which means I can ask in 2 ways. If I have, for example, a place, and I can put the keys on it, map the keys, and then there's number 5. So place is number 5, it's here. And this would make friends number 5. Or I can say keys from place. Like this. Or key place of word. Yeah. Word is people. Good. People is number 1. Good. To change, now we want to put the, or building, for example. Let's take a look what is building. It's number 2. So this means the points from building for people means I want to add 1 point here, another 2 point, another 3 point, then with people 0, with people 3 points, and so on and so on. I want to add it to my friendship. So how to change elements in this list? This is done with replace part. So we say friends. Can look it up here, but it looks like, so I change 1, or let's take 3, by, for example, 5 points. So and then you see this is a new list. Element 3 changed by value 5. So here is what we have to do next. So we say points 1 so this here is, let's have a look, points 1 is this. Now we want to go for the first element, this is building, and we want to have the key of it, whatever the keys of it. So it's number 2. So therefore we can say this here, you can put it here. So we get 5 points for building. So the same here. Now we go for points 2. It's the second element of points, so points worth this. If we go for 1, 2, we have the 1. So this is here. Now because building is on 2, 1 point, we have 1 point here. That's nice. Now we want to do it with all the points. Therefore we have to put that a variable and say all the points. So keep that off. It's very mechanic. So say this is a principal function, it's a pure function, and get points out of 1. So you recognize the symmetry. So this should have the same result. You see, it's fine. Now I simply can say I map it, which means now I can say 1, 2, 3. Now I get 3 times adding to the list. So, but they are in sequence. So it's with point 1, with point 2, with point 3. And for these things, as these things are of the same size, I simply can say total of this. I can add these vectors, and this is our total list. If I do that for all, I have all the points. And I can leave that, zack. This is our friendships. Is this. Good. Now we are here. What we have is, if we want to compare these words, they need to be we call it normalized. It's a little complicated because as a conception, what we have now is with these numbers. So if there is a word, for example, which has a lot of talks, people has a lot of talks, system has fewer talks, then this vector here of friendship gets smaller. So the length of this is the amount of talks. What we are interested in is the direction of talks of this multidimensional vector. So therefore we project the vector to the length of 1, which then is just not any longer a vector, then it is a direction to a sphere. And then we can compare these vectors independent of the frequency of the amount of talks. So then we have we are not interested in the length, but in the direction of it. It's circular and linear. Circular is always the irrational part of it. So therefore we go here for normalize this. Then we get these parts, and to make it more readable and faster in calculation, we put that to float numbers, computable numbers. So this is our direction in a 36-dimensional space, a sphere of the friendships of our worked people. So this is a characteristic vector of people, of the people vector. Good. Now we want to summarize it because we want to do the same thing with all the words we selected. So now let's look for a function. What we had. So the words, this is, we have a number of words here, we need that. It's not specific. So this is specific, words here, position, word sequence. We look for the length word sequence, it's good. Talks is not expensive. The talks of this word, this is okay. We don't need that. The weights, we need that. And we have the points of all the buildings, of all the talks, the friends. Good. We have that, the keys. It's not expensive. And the friendship. So, you see it's fast. That's good. Expensive is the calculation here of the word lists and so on. So we want to give that a name. So MTP book word friendship. So we will say it's what do we need? Let's keep it open, module, and then look what we need to run it properly. Let's have a So, people is our word, so we put that word here. This, don't we want to give that. Positions is in a word sequence. So, a word sequence, we need the word 100 sequence. So, positions is local. Length is local. We can make it global, but then we need to be careful with all the parameters. Talks is, we have that. Length, positions, we have that. Talks is local. Weight is local. We don't want to change it. Points is local. Weights, talks, yes, it's local. Green, friends is this is local. Keys, we have the words 100 here, so we put words 100, we need it here, words 100, so the keys is local, so and then normalize, replace, friends, so this should work then. So now friendship of the book, the word sequence, so we have the word 100 sequence. It can be a different name than here, but so now we have the words 100 words and then the word people. That's a vector. Good. This is working. Copy that and go to our and make that function available for further use. So that's a test of our function, and now we want to do this here for all our words. So words are 100. So we want to do it for the words on themselves. So we put that of, make a pure function, map it to each element of words 100. Very simple. And now here we are. Now we have an array of vectors of friendships. So you might wonder what it is. These are the friendships. So, and we simply can say array, to look at it, array plot of friendships. And here we are. Which means it's dark if there is a lot of correlation between these between these concepts, and it's white if not. So this might be, so this is okay. Now I have to now we want to see what we have there, and we want to be able to work. So we are interested in these friendships of words. So, and you can imagine that with different books, or with different authors, with different times, there are different patterns of these words. So, and then you can imagine that if two books are talking with each other, or they start to read each other, there is a mismatch in these understandings of words. So that's the interesting point we want to look at, without reading the books. That's always the interesting point. So for us, it's an entry point to ask proper questions to the book, to challenge the book. So what we use for that is a so-called click plane. We can check it. Click plane is this here. So you make an interactive thing. So you click here, and then it's getting interactive. So we copy that, and I show you how to adapt it. Here now. Click plane, evaluate that, go here. So what it does is, we have a dynamic module. This is like our module in the functions. This is a local variable, and this variable is dynamic. So like in our pop-up menu, we have two things. So it's dynamics, this is a click pane. Dynamic, it's a graphics. In this case, it goes from here to here. So, and this variable here is to the graphics. The graphics creates a yellow disk and a black point at this coordinates. So if we start, the point is at 0 because we put in here 0. So, but if we click, point is changed, which is done by the second part of the click plane. So click plane here, what to do and what to change. So this is a pure function. So my mouse click is put to point, and because this is a module and point is within this module, they have a shortcut, which means this is changed by the mouse click within the graphics, and then the graphics is redrawn, which means it puts the point here. So what we want to have is we want to click on our array, and then we get the coordinates to find the pairs of words of friendship. Therefore, we now go for this array plot and replace simply the graphics with the array plot of friendships. So it's important, which is a little annoying, is the 0 point of this array point is it's at the top left corner in a coordinate system with graphics, and as you expect, the 0 point should be down here. To get it turned as reverse the list of friendships, and then we are in a proper way. So good, take this or put this reverse here to the friendships, and now we have a click pane with that. Now we want to see what the point always says which kind of coordinate do I click. So to see that, we simply take it off here. So we have point x, put it here, points, make that 0, and make it dynamic of point. So then we have the points. Do that off. We have that dynamic here. Click plane, here we are, and if I click here, I see the coordinates of my click. So this should be 0, and this should be 36 by 36. So I think if we round that, then we get proper coordinates. This is 36, 35, or 2 to 12, 1, 1. No, it's not. Maybe we should have the ceiling. It's always rounding up. So this is 1, 1. This is 2, 2. This is better. Yes, now we are proper. Yes. Good. This is our click plane. This is our coordinate. So the 1 is from words. 100. These are here. So what we want to have is ceiling of that, and words 100 of ceiling from point 1. That's list, land, city, people, building. Okay, now friendships off, and we do the second one. And 2. Rooms and spaces. So these are the friendships. Building buildings, yeah, that's nonsense, so we need better curation. But here people need, that's for example interesting. Or we see life and community. Walls and wall, stupid again. Common, land, that's interesting again. Social spaces. So, and this is of space and spaces. We have to curate it in a better way. But you see the principal place building. So, and this is how to do it. Let's finish just with the comprehensive function of the last part. So that we directly can do this correlation. So what we need is library selected, the book selected, we say that's it. So we want to get this one, get the words of a book. Now the words 100. So the numbers of words, we need to get that as a parameter. Get this number of words, word sequence is a word, we need that as well as a parameter, people. So let's collect the parameters here. Number of words. We need the book selected. Book selected, number of words, and the word. Is it the word? No, we want to have all words. Okay. Talk points, but I think then we take this thing here. We don't need the positions. So word sequence, words 100. This is time consuming, and the rest is fast then. And we don't want to have it with people, we want to have it with all the peoples. Here we are with the friendships, and this is our click plane. This is what we want to deliver, and this is okay. Good. We can improve that later. And this is our function. This is not too much. So MTP book friendships. Off module. So, number of words. We need the book name, and book selected here. Book selected, book name. Okay, then number of words. So the words. Local, words 100, words 100 sequence, friendships, and here we are with the friendships. Click plane gets dynamic, so we need, we have that. Dynamic module. Now we are good here, and this is our, so in PT still black, we want to have it external, so we can work on it later on. So now let's check MTP book friendships of MTP book selected, 36 words. This is our array, and this is a click plane, and this should work here because PT is the same like here, and you see it's working. So what we want to have is that we want to have a nice name here, and for that we take this and put it here. We want to get this here. Words 100 is part of this. So we have dynamic array plot, friendships, and we say word pair selected is, and we put this $sign here because it's a global variable, and this is point, and the point 1 comes from the mouse. Pure function on this list. That's it. Now if we start this, we have it. Now we ask for a dynamic of word. We have a problem here. Word 100 ceiling. Go back, this should work. It doesn't. I think I just forgot this. Yes, otherwise this pure function is just after the assignment. This should work here. Yes, these are the coordinates. Now let's do the same with here. So process it. This is, and this should work now. Yes, here we are. Take this. And put it here as a comprehensive function to analyze and characterize the language of a book. This is a comprehensive function. This is all you have to do if you want to use it. Go to another book or to another resolution, and here you are. Thanks for watching, and see you in the next tutorial.